Hello everyone, welcome once again to this online session. Today we are going to continue with the same chapter, that is chapter number 10, gravitation. Hope you all remember what we have done till date in this lesson. We have learnt what is gravitation, universal law of gravitation, how to derive the value for gravitational constant, that is your capital G, the formula also, the derivation of the formula for capital G. We have learned about the importance of universal law of gravitation because gravity is very important. It's a binding force. Those things we have learned. And then free fall, that is your acceleration due to gravity, and the derivation for formula for your acceleration due to gravity, that is your small g. And about mass and weight. We have learned mass and weight are two different quantities. Mass remains the same, weight keeps changing. These things we have learnt already. So almost all topics are over. The rest of the topics, that is your thrust and pressure, buoyancy, Archimedes principle, these are all not included in your syllabus. This I have told you earlier also. Today, since we are going to do some numericals, I'll start with the calculation of weight of an object on the moon. Okay, first of all, you should know what is weight. You know the formula for weight because mass and weight are two different quantities. If an object has a mass of 100 kg on the earth, the mass will remain the same when the same object is dropped in moon, but its weight will change because weight is a product of mass and acceleration due to gravity. Acceleration due to gravity keeps changing. Therefore, weight can be defined as the force with which an object, that is a particular place, attracts the object on it. Suppose when I talk about weight of an object on the earth, it is a force with which the earth attracts the object. In the same way, when I talk about weight of an object on the moon, I can define it as the force with which the moon is going to attract the object. So we all know that mass of the moon is less when compared to the mass of the earth. Therefore, the moon will obviously exert a lesser force of attraction on the object because its mass is less when compared to the mass of earth. Clear to you? Okay. Now, let's find out which formula we have to use for calculating the weight of an object on the moon. See, while doing this universal law of gravitation, when I had taught you to derive the formula for calculating capital G, we have calculated the force which is applied by the earth on the object. F is equal to G mm upon r square. M stands for mass of the earth, small m stands for mass of the object, capital G stands for gravitational constant, and r stands for radius, that is the distance. In the same way, I just now said weight is nothing but the force. In that case, the same formula can be used for calculating the weight of an object on the moon. So let's assume the mass of the object to be small m, weight of the moon to be weight of the same object on the moon to be Wm, that is weight of the object. Then mass of the moon to be capital M and radius to be capital R. When you apply universal law of gravitation, I said the formula that we use for capital F, force with which the earth attracts the object, the same thing because weight is also a force. So that F is replaced by Wm here, G mm into M upon R square. So your capital M stands for your mass of the moon, and small m stands for your mass of the object, and R stands for the radius, and capital G stands for your gravitational constant. Okay, now see, it is calculated that weight of an object on the moon would be 1/6 of the weight of the same object on the earth, that is less. We have learned why the weight is going to be less when it goes to moon, because weight is a product of mass and acceleration due to gravity, and the acceleration due to gravity of moon is less when compared to that of earth. Obviously, its weight will also be less, the weight of the object on the moon. We'll understand this with an example. This you have to remember. Weight of an object on moon will be 1/6 of its weight on the earth. What is the reason? Because acceleration due to gravity, that is less, and mass of the moon is also less when compared to the mass of the earth. Okay, those two quantities you can write. Next, if an object weighs 10 Newton, I've given it as weight, and Newton, this Newton itself represents that it's a force. So weight is a force. Okay, so if an object has a weight of 10 Newton on the earth, the same object would weigh 1.67 Newton when it is placed on the moon. Why? Because an object on the moon would weigh 1/6 of its weight on the earth. That's the reason. Clear? Now let's move to the numerical part. See, before I begin with the numericals given under exercises, we'll solve the solved sums given in the chapter. So it will give a way for better understanding. See here, this sum is given to calculate the force exerted by the earth on the moon. See here, that's capital G value is given like that, capital G value, small g value, these things will be given to you. Okay, so let's see the sum now. This is a solved example. You can go through this in your textbook even. I'm just explaining how it is done. So further when we do the sums, it will help you for better understanding. See, the mass of the earth is 6 into 10 raised to 24 kg, and that of the moon is 7.4 into 10 raised to 22 kg. If the distance between the earth and the moon is 3.84 into 10 raised to 5 kilometer, calculated the force exerted by the earth on the moon. Calculated the force, they want you to calculate the force exerted by the earth on the moon. What are the terms given here? They have given you mass of the earth, they have given you the mass of the moon, and the distance between the earth and the moon. These terms are all given. They are just asking you to calculate the force exerted by the earth on the moon. And the value of capital G is also given as 6.7 into 10 raised to minus 11 Newton meter square kg raised to minus 2. So let's see how to solve this. First, what are the things given? They have given mass of the earth. We'll assume that as capital M, right? That is 6 into 10 raised to 24 kg. Mass of the moon is 7.4 into 10 raised to 22 kg. Then, distance between the earth and the moon is given as 3.84 into 10 raised to 5 kilometer. 3.84 into 10 raised to 5 kilometer. So this kilometer has to be converted into meter. So if you want to convert a kilometer to meter, what will you do? You'll multiply by 1000. The same thing I'm doing here. 3.84 into 10 raised to 5 is multiplied by 1000. When it is multiplied by 1000, 3 zeros are getting added, so I can increase the power, that is the index number, by 8, that is by 3. So it becomes 10 raised to 8. So the distance between the moon and the earth, that is 3.84 into 10 raised to 5 kilometer, when it is converted to meters, I get it as 3.84 into 10 raised to 8. And the value of capital G is already given. So what formula we are going to use here? We are going to use the formula F is equal to capital G into capital M mass of the earth, and small m is your mass of the moon, and D square, that is the distance, that is your radius, that is 3.84 into 10 raised to 8. And capital G value, see, the values are all given. Capital G is 6.7 and 10 raised to minus 11. Capital M, we saw, that is 6 into 10 raised to 24. Small m is 7.4 into 10 raised to 22. And then your distance, that is 3.84 into 10 raised to 8. That should be written as whole square, because the formula tells it as d square, or you can take it as r square even. Okay, so when you substitute all these values in the formula, that is 6.7 into 10 raised to minus 11 into 6 into 10 raised to 24 into 7.4 into 10 raised to 22 upon 3.84 and 10 raised to 8 whole square will give you 2.02 into 10 raised to 20 Newton. Newton is the unit used for force. For weight also you have to apply the same unit. Okay, in the next class we'll proceed further with the sums. Okay, like what would be the weight of an object if it has a mass of so and so on the earth. So how to calculate its weight on the earth? That is by using the formula m into g. So g on earth will be 9.8. We'll substitute those values and we'll calculate that. And there are many sums based on this. So this is an example. So you just go through this. The lesson is getting over here. Now we have to start with numericals and other exercises that we'll be doing in the next lesson. So in this lesson, as far as this lesson is concerned, you have to be thorough. I mean, I'm telling about the important things that you have to focus on. You have to learn what is gravity, what is universal law of gravitation. Gravity, you all know, it's a force with which the earth attracts the object that are coming towards itself. Gravity is nothing but a force, you can say. Then universal law of gravitation. Every object in the universe attracts every other object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Then we have calculated the value for, the formula for capital G, right? And then a free fall, when the objects are falling only due to the force of gravitation exerted by the earth on it, is what is called as the object showing free fall or acceleration due to gravity. That is your small g. Its value on earth is 9.8. And what is mass and what is weight? This is very, very important. Mass and weight are two different quantities. See, mass is the quantity of matter contained in an object. Weight is a product of mass and acceleration due to gravity. Mass remains the same, weight keeps changing. So this I'm stressing again and again, means these basic things you should be thorough of. So now what you have to do is you have to take your textbook and revise what is taught till date. And in the next class I'll proceed with few sums, because we'll be focusing only on the sums related to your acceleration due to gravity, gravitational constant, force, weight and all those things. Because the rest of the things like thrust, pressure, buoyancy, these are all not included in your syllabus. Okay, so things are going to be very, very easy. You don't get scared. Just read your textbook thoroughly. That is more important. Okay, take care. Meet you very soon in the next session. Till then, bye.